Good day, everyone. Welcome to this presentation on behalf of Innovative Embedded Systems Incorporated. Today, our engineering team will walk you through a critical design decision for our latest project, selecting the right digital logic family for the next-generation smart home embedded control system. This device will power modern homes by connecting sensors, wireless modules, and user interfaces into one seamless experience. The logic family we choose will directly shape how well that device performs, how long its battery lasts, and how affordable it will be for consumers. Throughout this presentation, all cost figures are expressed in Philippine peso, so our analysis reflects real-world pricing in the local market. Here is a quick overview of what we will be covering today. We will start by introducing the project background and our objectives for this analysis. Then, we will break down the system's 5 core requirements, followed by a side-by-side comparison of all the digital logic families under consideration. From there, we will present our recommendation, discuss the trade-offs involved, and show you the actual IC components that correspond to each family. We will close with our conclusion and the next steps for the project. By the end of this presentation, you will have a clear and well-supported understanding of which logic family best fits our smart home device, and why. Let's begin with some context. Innovative Embedded Systems Incorporated specializes in designing embedded systems for consumer electronics, automotive systems, and industrial automation. Our current project is a next-generation smart home device. This is not a simple gadget. It needs to integrate multiple environmental sensors, such as temperature, humidity, and motion detectors. It will also include Wi-Fi and Bluetooth communication modules and a touch-based user interface for homeowners to interact with. Now, here is the critical question. What digital logic family should power all of this? That single decision will cascade across the entire design, affecting performance, battery life, cost, and the long-term reliability of the product out in the field. To answer that question well, we set 4 clear objectives for this analysis. First, to understand the trade-offs of each available logic family. Second, to evaluate the system's specific requirements. Third, to justify our recommendation with real data. And fourth, to present those findings clearly to you, the management team, so we can move forward with confidence. Before we can compare any logic families, we need to clearly define what our system actually requires. There are 5 non-negotiable requirements for this device. First, performance. The system must process data from multiple sensors simultaneously in real time. That means propagation delays must be 10 nanoseconds or less, and the data bus must support 8 to 32 bits to interface properly with the microcontroller. Second, power consumption. This device is battery-powered. We are targeting a 2000 mAh lithium-ion cell. Low power consumption is not just a nice-to-have, it is a product requirement. A logic family that drains the battery in 10 hours simply will not make it to market. Third, cost, expressed here in Philippine peso. To stay competitive in the consumer electronics market, the bill of materials must be lean. Every peso saved on components contributes directly to the product's retail price and margin. Fourth, integration. The logic family must play well with our other components. Microcontrollers like the ESP32 or STM32, flash memory, Bluetooth and Wi-Fi system on chips, and communication protocols like I2C, SPI, and UART. And fifth, reliability. Smart home devices go into living rooms, kitchens, and garages. The device needs to operate dependably across a wide temperature range and resist electrical noise from nearby Wi-Fi radios and switching power supplies. Now let's put all 5 logic families side by side and see how they stack up against our requirements. The 5 families we evaluated are transistor-transistor logic, or TTL, complementary metal oxide semiconductor, or CMOS, emitter-coupled logic, or ECL, BiCMOS, and low-voltage differential signaling, or LVDS. TTL is fast, and it's inexpensive at around 6 to 28 pesos per IC. But its power consumption is high, which immediately makes it a poor fit for a battery-powered device. CMOS checks almost every box. It offers moderate to high speed, very low power consumption, excellent noise immunity, and the lowest unit cost of all 5 families, just 3 to 17 pesos per IC. It is also the most compatible with modern microcontrollers and wireless modules. You will notice that the CMOS row is highlighted, and that is intentional. This is our recommended choice. ECL is the fastest family by a significant margin, but it comes at a steep price on every front, over 112 to 560 pesos per IC, very high power draw, and poor noise immunity. For a battery-powered consumer device, ECL is simply not practical. BiCMOS offers a nice balance of speed and low power at a moderate cost of 28 to 112 pesos. It would be a strong secondary option. However, it costs more than CMOS without providing benefits our application actually needs. LVDS is excellent for high-speed data transmission and has good noise immunity and low power. But at 45 to 168 pesos per driver-receiver pair, and with added PCB routing complexity, it is better suited as a targeted solution for specific high-speed data lines, not as the primary logic family. Based on our analysis, the recommendation is clear. We should design the smart home embedded control system using CMOS technology, specifically the 74HCXX high-speed CMOS series. Let me walk you through the 4 key reasons. Battery life. CMOS consumes dramatically less power than other families. In a battery-powered device, this translates to an estimated 100 to 200 hours of operation per charge cycle. Compare that to a standard TTL-based design, which would last only around 10 hours. That difference alone is a deal breaker for every alternative. Unit cost in Philippine peso. At 3 to 17 pesos per IC, the 74HCXX series is the most affordable logic family available. For a product that needs hundreds of logic gates across its design, keeping each gate at this price point significantly reduces our total bill of materials. This keeps the product competitively priced for Filipino consumers. Noise immunity. CMOS uses MOSFETs with very high input impedance, which gives it excellent tolerance against electrical noise. This is crucial in a smart home device that will be sitting next to Wi-Fi routers, Bluetooth speakers, and switching power adapters every single day. And finally, compatibility. The 74HCXX series operates at 3.3 to 5 volts, which is the standard voltage range for the microcontrollers, memory chips, and wireless modules we are already planning to use. No expensive voltage translation hardware needed. As stated in our reference, Logic Circuit by EduHeart Book Publishing, CMOS is widely used in microprocessors, microcontrollers, memory chips, and other digital logic circuits due to its low power consumption, high density, and flexibility. This is not just our opinion, it is the industry standard. This slide puts the numbers into sharp visual focus. The bar chart on the left shows average power consumption in milliwatts for each logic family. Look at the ECL bar, 500 milliwatts. Then look at TTL, 200 milliwatts. Now Look at CMOS, just 10 milliwatts. That is 20 times less power than TTL and 50 times less than ECL. Power consumption matters in a very direct way for battery-powered devices. The more power a logic family draws, the shorter the device's battery life. This chart makes the advantage of CMOS immediately visible. On the right, we have the unit cost per IC in Philippine peso. CMOS comes in at 3 to 17 pesos, the lowest of all 5 families. TTL is slightly higher at 6 to 28 pesos. BiCMOS and LVDS sit in the moderate range at 28 to 168 pesos, and ECL sits at 112 to 560 pesos per IC, which, for a mass-market consumer product, is simply not viable. In short, CMOS wins on both axes. Lowest power consumption, lowest cost. When you are designing a battery-powered device for the consumer market, those two factors together make the decision straightforward. No technology choice is perfect, and we want to be fully transparent about the trade-offs of choosing CMOS. The good news is, each trade-off has a practical, low-cost mitigation. Trade-off 1. CMOS is slightly slower than ECL or BiCMOS at extreme switching frequencies. However, for our application, this is essentially a non-issue. Our sensors operate at 10 to 100 Hz, nowhere near the gigahertz range where this speed gap would matter. Using the 74HCXX high-speed CMOS series for time-critical signal paths is more than sufficient. Trade-off 2. CMOS gates are sensitive to electrostatic discharge. This is a real concern during PCB assembly. We mitigate this by enforcing ESD safe handling procedures on the production floor and adding transient voltage suppressor diodes on all exposed I/O lines. Trade-off 3. Power consumption increases at high switching frequencies. Again, at our sensor polling rates of 100 Hz or less, the power increase is negligible. Implementing firmware-level duty cycling and sleep modes will keep power consumption well within budget. And trade-off 4. If we need to interface with any legacy 5-volt TTL peripherals, there is a voltage mismatch. The fix is simple and inexpensive. Either use the 74HCT series, which accepts TTL level inputs natively, or add dedicated level shifting ICs at an estimated 56 to 280 pesos per board. All 4 of these trade-offs are manageable within our existing engineering and production processes. None of them changes the recommendation. Now, let's make this tangible. These are the actual integrated circuit components we evaluated. One representative chip from each logic family. Starting from the left, the SN74LS00N represents the TTL family. It is a standard quad NAND gate IC running on 5 volts. At 6 to 28 pesos per chip, the price is affordable, but the power draw disqualifies it for our application. Next, the 74HC00N represents our recommended CMOS family. This is a high-speed CMOS quad NAND gate operating at 3.3 to 5 volts. At just 3 to 17 pesos, it is the most cost-effective component on this board, and it is the one we are recommending for the smart home device. The MC10101L represents ECL. This is an emitter-coupled OR/NOR gate running on 5 volts. It is the fastest chip here, but at 112 to 560 pesos per IC, it is 30 to 40 times more expensive than CMOS. Combined with its high power draw, it is impractical for a battery-powered consumer device. The 74BCT244 represents BiCMOS. It is an octal 3-state buffer running on 5 volts, priced between 28 and 112 pesos. It is a capable component and would be considered for specialized high-speed subsystems if needed. And finally, the SN65LVDS31 represents LVDS. This is a quad differential line driver operating at 2.5 to 3.3 volts, priced at 45 to 168 pesos per package. It is excellent for high-speed data transmission lines, such as camera or LiDAR feeds, but is not the right fit as the primary logic family for our device. All prices shown are in Philippine peso at an approximate exchange rate of 56 pesos to $1. To bring everything together, our final decision is to adopt CMOS technology, specifically the 74HCXX high-speed CMOS series, as the digital logic family for the smart home embedded control system. At 3 to 17 pesos per IC, it is the most cost-effective choice on the table. Let's revisit how it meets every one of our 5 requirements. Performance. The 74HCXX delivers propagation delays well within 10 nanoseconds, fast enough to handle real-time processing from all our sensors simultaneously. Power. With ultra-low static power consumption, the device is projected to deliver 100 to 200 hours of battery life per charge. That is a compelling product specification for any smart home appliance. Cost. At 3 to 17 pesos per IC, CMOS is the most affordable family by a significant margin. For a mass-produced consumer device, this directly improves our competitiveness in the Philippine market. Integration. The 74HCXX series is fully compatible at 3.3 to 5 volts, matching the operating range of every microcontroller, memory module, and wireless SoC in our current design. And reliability. CMOS operates across a wide temperature range and provides excellent noise immunity, giving us confidence that the product will perform dependably in real-world home environments. Our next steps are: build a prototype PCB using 74HCXX ICS, conduct thermal and power consumption testing, and then move to field reliability validation before final production sign-off. Thank you for your time and attention today. To summarize in one sentence, CMOS at 3 to 17 pesos per IC gives us the best combination of low power, low cost, high noise immunity, and broad compatibility for our smart home device. It is the right choice, and the data supports it at every level.